some notes at the beginning. Could you please go back to take a photo to that, please?
You want to check the configuration on firewall or this one?
Yeah, yeah, that is correct.
Oh,
That is correct.
yes.
I would like to have
Okay.
a screenshot of this part.
Yeah, yeah. Okay, and I'll show you. I'll show you. I'll show you from the beginning. All right. A drag a cloud. Drag a cloud. UDP add and this one
Oh yeah.
192.168.0.10. I don't know the IP address of your ENSP desktop. In my desktop is 10.0. Maybe yours is maybe 100 or 2 or some other IP address. Can you see that?
Yeah.
It should be 10, right? Okay, this one. Choose this one. Add.
Okay.
And then UDP. Add. So after we add the port building, it should be 3. First one, UDP. Second one is the network adapter. And the third one, UDP. And why we need 3 is about 1 and 2 create a port, and 2 and 3 create another port. So port mapping setting 1 and 2 two-way channel add. This is the first pair, right? First pair of the port mapping. And the second pair is 2 and 3 local port number 2, a remote port number 3 two-way channel add. Okay, and that's finished.
Oh yeah. Okay. Okay.
Yeah, is it
Thank you.
clear? Yes.
Thank you. That is what I need.
Yeah. So after you finish the configuration of this one, if you use the copper, try to connect this cloud into some devices, you can find there are 2 interfaces, right? Ethernet
Mhm.
001 and Ethernet 003. And this is that's 2 pair, first pair and the second pair. Okay. And that corresponding to 2 interfaces. Okay, good. It's almost 1.5 hour. I think we can take a break. All right, take a break. And if you're interested in this part, you can try to finish this simulation practice by yourself. 10 minutes break. Okay. Do you need some time to practice by yourself? If you need time to practice, I can wait. Maybe I can give you about 20 to 30 minutes to practice by your own. And if you want to just move to the next part, then we can move on. It's up to you. Practice. Good, good. Then 30 minutes, all right? 30 minutes. And if you have question, send me message and I will help you to finish that. Could you explain again the cloud config and the firewall starting config? Got lost on the credentials and after binding. Okay, I'll show you again. So the first step is how to configure the cloud, right? The reason why we need to use the cloud is the cloud is just like the bridge connecting with the ENSP firewalls and this Windows system, because we need to use this desktop Chrome, the browser, try to open the website page of the ENSP firewall, and the cloud is just like a bridge. This is the reason why. And then is the configuration of this cloud. So the first should be, you can see this view, you can see this window, right? Binding info, UDP. By default is UDP, right? Add new one. Okay, and then choose this one, 192.168.0.10. This is another network adapter. I believe that if you're using the E-class desktop, you can see this network adapter, and IP address is just like this. Okay, and choose this one. Oh, sorry, choose this one, and press the button, this add. Okay, and we still need another UDP, binding info port. So add. After triple add, there are 3 ports. And first is one UDP port, and another is the network adapter, and third one, the second UDP, 1, 2, 3. Okay, then the port mapping. We need to bind the first UDP to the second network adapter. This is one pair. This is one pair. One pair corresponding to the cloud, one interface. All right. Okay. So 1 and 2 bind together, right? Local port number 1, remote port number, we choose 2. And don't forget this two-way channel. After that, we press this add. Okay, we just create one pair of binding. One pair of binding means one interface on that cloud. But one interface is not enough. Why? Because there are 2 firewalls. In this topology, we have 2 firewalls. So we need 2 interfaces on the cloud. But now we just have 1. See? We just said, sorry. We still need another one. I think it is not correct. Local port number 2 and 3. 2 and 3. This one and this one bind together as another port and add. Okay. And it is finished. 2 port, right? 001, 003. You can choose 001 to connect with the firewall 1, interface G000. And you can use the cloud 003 to the firewall 2, interface G000. All right. But you have to pay attention that the cloud connect to the firewall. The managed port must be G000, because I told you before, the G00 interface is the managed port. It is used to manage the firewall, all right? Not the traffic, not traffic forwarding, okay? And after you finish this, connect the cloud to the firewall, then the first step is to remodify the password, account name and password. And the default account name is admin. And default password is admin at 123. And first, A, the first A, admin at 1, 2, 3, first A is uppercase, all right? And after you input the default username and password, the firewall will ask you to change the password. So you choose yes and change the password to Huawei at 1, 2, 3. Okay, after you finish the password changing, then you need to configure the interface of G000. Interface G000. Interface G000. All right. And several commands. First, service manage pin permit. And second, service manage HTTP permit. And third, service manage HTTPS permit. Okay, I'll show you. This is the configuration. I'll paste the interface configuration on here. This is the firewall 1 interface G00. And actually the firewall 2, just ignore this 2 line, useless. And firewall 2, same, but firewall 2, we need to modify the IP address to 2, not 1, right? Okay, is that clear? Sosa, I just explained. After we finish the interface G000 configuration, then you can use your Chrome to open the website page of these 2 firewalls. Hello? Sosa. So there is no need to do IP binding VPN instance. And another question. Yeah, no need to bind the VPN instance. Okay, no need to bind the VPN instance. And another question. Every firewall I'm creating is a configuration made by default. Like the device do not ask me for credentials, and there is a sysname already configured. We need to configure the sysname by ourselves, all right? Just like that, sysname firewall 1 and sysname firewall 2. And the default part is the IP address. Okay, let me show you the default configuration of interface G000. Undo shutdown is the default configuration. And IP binding VPN instance is the default configuration. These 2 don't need to change. And third one, alias GE0 METH. This is the name of this interface, no need to change, all right? We just focus on IP address of the interface G000 and these three commands. And for the authentication, credentials, like the defaults, do not ask me for configure by default. Like there is the last question is that I think someone already configured the firewall. It shouldn't, because your ENSP is during this course, your ENSP is just controlled by you. No one can log in. If you find the firewall configuration is not correct, you can drag another one. Here is the firewall. Can you see the firewall? USG 6000V. Drag a new one and start it, and delete the old one. You can configure one firewall from the start. Okay, good. And what about the rest of you? What about the rest of you? I hope that each of you are trying to do this practice. Okay. It's already 10 o'clock. It's already 10 o'clock. After class, if you're interested in this practice, you can finish by yourself. Try to finish by yourself, all right? And I think it's about time to move to the next part. Firewall host standby technologies. After we finish this chapter, this part, IPS, user managed technologies, PKI, and encryption technology applications. Actually, this part, number 11 slide is the VPN, but just the introduction of VPN, not so detailed. So we can still use the ENSP to do the practice of this part, host standby technology and user management, and this one, IPsec VPN, L2TP SSL. But SSL, ENSP cannot simulate. ENSP cannot simulate the SSL VPN. I've tried before. Okay, so let's start this part, firewall host standby technologies. As the name suggests, host standby is used to meet the requirement of availability, right? In the first week and the second day, yeah, I believe it's the second day, I mentioned 3 words of cybersecurity. That's the key. That's the key. The first word is, do you still remember? Confidentiality, availability, and integrity, right? And the firewall host standby technology meet the availability, which means if we have a pair of firewall deployed on our live network, if one firewall is broken, for example, the link between the firewall A and the switch is down, it's okay. We still have firewall B. The backup one can still forward the traffic. All right. And that's the meaning of hot standby. Since it is hot standby, the keyword, we need to pay attention to this word, HOT, hot. Why it is hot? Which means the firewall can detect the status of themselves automatically. If the firewall A is broken or the link is down, then the firewall A will realize, okay, maybe one of my link is down, one of my interface is already can no longer work with the business. Then it will tell the firewall B. Then firewall B will take place of the firewall A automatically. And that's the meaning of this hot, which means auto. Auto. If it is cold standby, what is cold standby? Cold standby means I have another firewall and I haven't turned on that firewall. I put this firewall on the warehouse. If the firewall already work on the live network is broken, then I take the broken firewall away and put the new one instead of it and turn on. And that's cold standby. But for the reliable network, for availability, we need hot standby. Okay? Yeah. And there's another word called single failure point. Single failure point. For example, this is a topology. Router, firewall, switch, and this is PC or server. If one device, any device is down, the whole forwarding path will down, right? If the switch is down, okay, the traffic will blocked here, blocked. If the firewall is down, the traffic will block here. So this is called a single point failure. A single point failure. Failure. We need to avoid this. For engineer, for the network designer, we have to think about this. All right. So that's why when we see the topology of some big company, of some standard network, we can always see a pair of device. In that a pair of device, the two devices is totally same hardware, same software, same configuration. All right. But actually, it's not all the configuration because the IP address of the layer 3 device should be different, right? If the IP address remains the same, maybe it causes trouble. IP address duplicate, right? I believe that on the last part, I tried to configure the NAT, and I just made a mistake. I configured two same IP address on two different devices, and they are direct link. And the traffic is down, cannot forward because two IP address is the same. So almost all the IP address of the hot standby device, the configuration is almost the same, but not all the configuration. All right. Okay. So let's see the logic of the traditional hot standby technology, and that is called VRRP. VRRP. Virtual Router Redundancy Protocol. Virtual Router Redundancy Protocol. We can check the this one. See that? Virtual Router Redundancy Protocol. It can detect the router, each other. If one link is down, another one become the master. So here's the word, master and slave. Master and slave, two status. For this pair of router A and B, router A by default is the master one, and the router B is backup. Another name is called slave, master or slave, active or backup, master or backup, same meaning. All right. And by default, the traffic is forward, path through the left side forwarding path from the internet host to the switch to router A to internet. All right. And if the router A is down, which means the link between the router A and the switch, this link is down, and the VRRP protocol will send some, there is a detect mechanism. The router B will find, wow, my neighbor is down. I say hello to him, and there's no response. I say hello to that router A 3 times, and I can't receive his response. Then I will change my status from backup to master. So that's the logic. All right, that's the logic. But how does VRP work? Okay, for example, this is a router, L3 device. L3 device. What is the working principle? This is switch. All right, router 1. Interface of router 1, for example, this one is 0, 0, 1. And on router 2, interface still 0, 0, 1. Same port number. And we configured a pair of IP address on these two interfaces. For example, this one is 10.1.1.1, and that interface IP is 10.1.1.2. Okay, and there is a PC. Okay, here is the network, ISP network. For the PC, the PC need a gateway, right? And we assume that the PC IP address is 10.1.1.100. All right, 100. But the PC just not one. We have several PCs, right? And in this network segment, 10.1.1.0/24. This is a network segment. Inside of this network segment, there are so many PCs, so many terminals, and they all need a gateway. A gateway. But here is the question. For those PC, when they want to configure a gateway, they need to choose 10.1.1.1 or 10.1.1.2. This is the problem, right? If we choose 10.1.1.1 as the gateway of these PCs, yeah, it is okay, we can use. But what if the link between the router 1 and the switch is down? And though for those PC, the gateway still remain 10.1.1.1. But actually, this IP address is not available anymore because the link between the router 1 and switch is down. So the traffic cannot go this side. Cannot go this side, left side. No, not available anymore. So, which means the PC, if the PC want to visit the ISP network, which means the internet, they need to change its gateway and change to 10.1.1.2, right? This is not VRP. This is called cold standby. It's not hot standby. So for VRP, another concept is called VIP. VIP, virtual IP. not very important person. Virtual IP. So the router 1 and router 2, now they will run the VRP protocol and they will create a VRRP group. VRP group. And inside of this group, basically, there are 3 IP addresses. First IP address 10.1.1.1, and the second IP address 10.1.1.2. And these 2 IP addresses belongs to the router 1 and router 2 and cannot be changed. It's fixed, already fixed. But the third IP is the VIP. And it is also the gateway of the PC, of the PCs. For example, their gateway should be 10.1.1.254. So this is the IP address of VIP. Why it is called VIP? Because it is virtual, not a physical IP address. It can be moved, it's not fixed, it's flexible. By default, if the router 1 is the active device, and the router 2 is the backup device, okay, then where's the eraser? Oh, here. Okay. By default, if the router 1 is active device, then the VIP 10.1.1.254 belongs to the router 1. Router 1 have the permission to use this 10.1.1.254. All right. And the router 2 otherwise don't have the permission to use the 10.1.1.254. But there are 2 questions, right? There are 2 questions. First question, how to determine the router 1 is the active one and router 2 is the backup one? This is the first question, right? How to determine? And the second question, since the router 1 is the active device and he can use the 10.1.1.254, the VIP, but how to guarantee that? How to make sure those PCs send the traffic go this way, go the left side, right? How to control? This is the second question. Okay, then let's answer the question one by one. Question 1, how to determine which one is active and which one is backup? The answer is priority. Priority. It's just like the security priority, right? And VRP also have the mechanism of priority. If the priority is good, which means the router 1's priority, VRP priority is better than the router 2's priority, then the router 1 will become the active and the router 2 become the backup. But how to compare? Okay. How to compare the priority? At the beginning of the router 1 and router 2 initialize the VRP. They will try to send the VRP hello packet to each other across the SW. See, that's why this device is a SW, is a switch layer 2 device, not layer 3. Because if it is a switch, the VRP can cross the switch and send to the remote side. So at the beginning, router 1 and router 2 will send a VRP hello packet. to each other, right? And inside of the VRP hello packet contains the priority, and router 1 and router 2 compare. Okay, then the router 2 find out, oh, my neighborhood, his priority is better than me. So I will let him to become the active one. I am the backup. That's the procedure. Easy. All right. So after negotiation, after this comparison or election, the router 1 becomes the active one because his priority is better than the router 2. Okay, this is I just answered this first question, how to determine which one is the active and which one is the backup. And the second question, since the router 1 is the active one, how to control those PC, send the traffic to the left side, not the right side, right? Okay, so the question is, once the router 1 becomes the active VRRP router, it will send one kind of packet, and it is called gratuitous ARP. Gratuitous ARP. I think we know what is ARP, right? We can use ARP to get the MAC address. For example, PC1 and PC2, they try to communicate with each other. Yes, they know the IP address of each other, but they don't know the MAC address of each other, right? So they need to ask. If it is PC1 try to access the PC2 proactively, the PC1 will send a ARP message, a broadcast to every devices inside of this L2 broadcast domain, which means the PC2 can receive that. PC3, 4, 5, 6, 7 until 100, they can all receive a ARP broadcast. And inside of that ARP request packet, it's just like, I am PC1. My IP address is 10.1.1.100. Could you please tell me the MAC address of 10.1.1.101? I don't know his MAC address. Okay. If now the PC2 is the 10.1.1.101 and he received the message, okay, I'm the PC2. I have heard something. Someone is asking me my MAC address. So I will reply the PC1. So then the PC1 get the message from the PC2. It is called ARP reply. And PC1 just got the MAC address of the PC2. So they can communicate with each other. And during that procedure, the ARP reply message is sent because someone asked somebody, right? It is because PC1 asked someone, oh, please tell me the MAC address of 10.1.1.101. Then the PC2 reply to PC1. But for the gratuitous ARP, things are different. The router 1 will keep sending the ARP message of this interface continuously. That is to say, the router 1 now have the permission of 10.1.1.254, right? Okay, now the router 1 will keep sending this message. L3, IP address 10.1.1.254, and my MAC address. This is L2 information. MAC address. Actually, the MAC address of a VIP have a specific format. 0000 dash 5E00 dash 010 actually X. All right, YX, depending on the VRRP group number. If the router 1 and router 2, this pair of IP address 10.1.1.1, 10.1.1.2, they generate a VRRP group, right? And the VRRP group number is number 1. Then the MAC address, the VIP's MAC address is 0000 5E00 0101. See that? The last number equals to the VRRP group number. All right. Okay. The router 1 will keep sending this message without somebody asking. It will send the gratuitous ARP periodically, automatically, proactively. The router 1 will send this thing to the switch. Okay, then after the switch receive the message, yeah, of course, the switch can read this thing. And we know for a layer 2 device, the most important table is called MAC table, right? MAC table. But what's in there of a MAC table? For a MAC table, the key information is the mapping relationship between the port and the MAC address, and of course VLAN. Port, MAC, and VLAN. But in this case, we just focus on these two, port number and MAC address. All right, and we assume that the interface for the switch direct connect to the router 1 is the interface G0010, all right, 0010. And since the router 1 sent gratuitous ARP message to the switch periodically, so the switch will learn some information from this message. Okay, then the switch will update its MAC table. And the port number 0010. And MAC address, this one, the VMAC, right? VMAC 00005E000101. All right. Okay. Now, inside of the switch, the MAC table, there is one entry. It describes the corresponding relationship, the mapping relationship between the VMAC, virtual MAC, and the port number. This thing is called VMAC. VMAC. All right. Okay. This is not the end, because the router 1 sent the gratuitous ARP. And see, this IP address, this is the gateway IP of those PCs, right? And it is ARP message. So this message will also spread to all the other interfaces of the switch, which means the PC1, PC2, PC3, 4, 5, 6, 7, 100, they will all receive the gratuitous ARP. And for those PC, they will learn one thing. The MAC address, the mapping relationship between the gateway IP and the gateway IP's MAC address, right? So all the PC down here know one thing. 10.1.1.254. And its MAC address is 0000 5E00-0101. This is the ARP entry, right? ARP entry. Every PC knows that. Okay. Now, if the PC1 try to access the internet, the first step is to find its gateway, right? Send this message to its gateway. So the PC1 send a message, and the destination MAC address is this 0000 5E000101 VMAC, right? DMAC, destination MAC. All right. Okay, send to the SW. And after SW, the switch receive the message which is sent from the PC1. Because SW is, the switch is L2 device. So it just cares about the MAC address. And it check the MAC address. Oh, the MAC address, destination MAC address is VMAC. And where is VMAC? Okay, check its MAC table. Oh, I find the VMAC is corresponding to 0010. The mapping relationship of VMAC is 0010. So the SW will send this message to the left side and finally access the router 1. And router 1, this is the L3 device, right? Okay, then check the destination IP, send to the internet. All right. I just answered the question 2. How to control the traffic of these PCs to go the left side? Any questions? For now on, am I clear? Is that clear? Yes. Okay, good. Mr. Sosa, I believe that you are a teacher, right? So you know those basic knowledge. What about the rest of you? Freddie, Daniel, Edwin. Do you have any questions?
For me, it's clear.
For you, it's okay. You have no question. Okay. Good. This is the working principle of VRP. First, they need to send the VRP hello message to compare the priority. If the priority is better, then the device will become the active one, and the remote side become the backup. And since the router 1 becomes the active one, it will send the gratuitous ARP to upgrade the MAC address table of the downlink switch. And that gratuitous ARP is used to guide the traffic sent to the active router. That's the meaning of gratuitous ARP. And at the same time, the downlink PC, PC1, PC2, 3, 4, 5, 100, will all receive the ARP message sent from their gateway. So they have the MAC address information. So the traffic can go the left side. This is the logic. All right. But there's another question. What if the link between the router 1 and switch is down? What about this link is down now? What will happen? Easy to see. If the link between router 1 and switch is down, which means the VRRP message cannot pass through SW and receive by the router 2. Right? So for the VRP packet, there is another packet is called VRP keep live, the keep live message or hello message. I forgot the detail, but the logic is the same. The router 1 and 2, since they established the VRP group, they will keep sending the VRP message to prove that I am still alive, right? So the router 1, if the router 1, the link is still normal, it will keep sending the VRP message and cross the switch received by the router 2 to show I am still alive, I'm still the boss. But if the link between the router 1 and switch is down, then the router 2 will never receive the VRP message sent from its boss, which means the router 2 realize, oh, my active router is down. Something wrong happened to him. So I will become the active one. Then the router 2, which its shift its status from backup to active. Then the router 2 have the permission of 10.1.1.254, have the permission to control the VIP. And that is to say, the router 2 start sending the gratuitous ARP, start to send the gratuitous ARP, and to refresh the SW MAC table, right? And those PC can also receive, but the PC have no sense. They just know, okay, the MAC address and the gateway, but the switch, the MAC table is changed. So the traffic will immigrate to the right side, not the left side anymore. Okay. That's how VRP work. And if you want to know more detailed thing, you can check the tips here, and you can view the training material. You can view the training material on the platform eClass. And this is the procedure. When the router A is working properly, which means the active router working properly, the traffic forwarding process like that, a virtual MAC address or VMAC. And when the router A is faulty, the traffic forwarding process is full. The VRP message will not receive by the router B, the backup. So the status shift happen. The backup becomes active. Okay, see that? Gratuitous ARP. Yeah, by using the VRP, we can establish the hot standby, dual system hot standby. But this is not enough. This is not enough. Why? We still have some issues. Okay. This is quite complicated. In this scenario, it is quite complicated. Firewall. Okay, firewall is also a L3 device, right? L3 device. So the firewall do have the IP address. And this is a pair of firewall. Firewall 1 and firewall 2. And the uplink of the firewall is, for example, a switch. A pair of switch, maybe. And the downlink is also a pair of switch. In order to facilitate understanding, so I just show you one switch. Actually, this is a pair of switch. Logically, just one. Okay. And for the downlink, the firewall 1 and firewall 2, they generate a VRP group. VRRP group 1. VRP group 1. And we assume that the IP address of this VRP group 1 is, 10.1.1.1, 10.1.1.2. Okay, VIP is 10.1.1.254. Okay, /24. This is not the end, because you can see the uplink is also a pair of switch. It's also switch, right? And the firewall 1 and 2 create another VRRP group. VRRP group 2. And the IP address of this pair is, for example, 20.1.1.1 and 20.1.1.2. And the VIP is 20.1.1.254. Okay? Yes, and by default, the firewall 1 has the better VRRP priority. But pay attention, because there are two VRP group, right? And the VRP group and VRP group between them, they are distinguished and isolated, which means they need to do the election independently. The firewall 1, VRP group 1, they finish the election and find out, okay, the firewall 1 is the active. And VRP group 2 also do election and find out the firewall 1 is the active one. So there are two VIP, all controlled by the firewall 1, because the firewall 1 is the active device, right? And remember what I said, between the VRP groups and VRP group, they are independent and isolate from each other, which means the VRP group 1 have no idea of VRP group 2. They cannot identify each other. That's the key. Okay. By default, the traffic is sent by, maybe this is a PC. Sent by the PC1 and received by the switch 1. Okay. It is because the VRP group 1, the active device is firewall 1. So the firewall will send the gratuitous ARP to refresh, to update the switch 1's MAC address table. So the traffic will guide to this way, the left side forwarding path. Okay, and go uplink and send to the switch 2. And when the traffic goes back, for example, this is a server. When the server received message which is sent from PC1, okay, it reply the packet received by the switch 2, and the switch 2 check, okay, the gateway is 20.1.1.254, and the MAC address is still the left side port. So the reply message go back to firewall 1 and send to the switch 1, right? Come and go. Request packet and reply packet go the left side forwarding path, both, right? Okay. What if the link between the firewall 1 and switch 2 is down? What will happen? Or, maybe this way. The link between the firewall 1 and SW1 is down. This link is down. Okay, if this link is down, the firewall 1 and firewall 2 will change the VRRP group 1 status, right? It is because the firewall 2 will no longer receive the VRP message from its boss, FW1. So the firewall 2, the VRP group 1, switch the status from backup to active or master. The meaning is the same, all right? Yeah. Then the firewall 2 refresh, send the gratuitous ARP message to refresh, to upgrade the SW1's MAC table. So the traffic will guide to this way, right? Okay. Yeah, go this way. The VRP group 2, the FW2 send the message to SW2. But for the uplink, the VRP group 2, the VIP is still controlled by the firewall 1, right? Because I said between the VRP group and VRP group, they have no idea of each other. So the VRP group 2 don't know what happened on VRP group 1. So the VRP group 2, the status still remains on the firewall 1. The firewall 1 still have the permission to control its VIP. I mean the VRP group 2, 20.1.1.254. Keep sending the gratuitous ARP. So when the server receives the message, okay, reply, right? And reply to the switch 2. And the switch 2 check its MAC table. The MAC table indicates that the VMAC still belongs to the port which is direct connect to the firewall 1. So the traffic will still go this way. Reply message, go back to the firewall 1. But the firewall 1, the link between the firewall 1 and switch 1 is down. So the reply message will never receive the switch 1, and will never receive the PC 1, which means traffic down, right? This is the problem of VRP. In one sentence, to make a conclusion, the VRP groups and VRP group between them, they have no mechanism, no such kind of mechanism to synchronize the status between each other, right? By default. So this issue happened. The firewall 1 and firewall 2, VRP group 1 and VRP group 2, the status cannot synchronize. It caused some trouble. Yeah, the traffic go this way, but back to this way. The request message go right side, and the reply message go back to the left side. But the left side, the FW1 and SW1, the link is down, traffic down, business down. All right. So how to resolve this problem? How to fix this issue? Okay, then we have another thing. It's called VGMP. Okay, but before that, I want to ask, any questions? Is that clear of the logic I introduced you about the VRP's problem? Any questions? Is that clear? Hello? Okay. Clear, right? See, I think the page but this training slide don't show us the problem. So I give you the logic. I explain you the logic. In order to show you this thing, VGMP, all right? It is because the VRRP cannot synchronize from each other. So we need this thing. It is called VGMP. VRRP, Group Manager Protocol, Management Protocol. So the function of this thing is easy to understand. Very easy to understand. VRRP, VRRP. Okay, this is group 1. And this is group 2. And once the firewall, this pair of firewall enable the host system, the dual system hot standby, okay, all the VRRP group will join to the VGMP group. VRP group management protocol, okay. VRP group 1 and VRP group 2 going to the VGMP. And VGMP will detect the status of each VRP group, which means if the link between the firewall 1 and SW1, this link is down, okay, then the VRP status, VRP group 1, the status change, FW2 becomes active, right? And it is because the VRP group 1 and VRP group 2, they join the VGMP group both. So the VGMP know what happened. Since the VRP group 1 status changed, then the VRP group 2 status should be changed also, right? So on the VRP group 2, same thing happened. The backup status changed to active. And this is called a synchronize, right? Synchronize. If one VRP group is changed, the rest of the VRP group change at the same time. In order to keep the come and go traffic go the same forwarding path, right? If we don't do so, the traffic go this way and back to this way, traffic down, right? But if we have the VGMP group, then the traffic, okay, the link between the firewall 1 and SW1 is done, right? So I switch the forwarding path to the right side. Go packet, go to the right side. And the reply message still go this way, right? The problem just resolved. But we still have one thing, still have one issue. Still have one issue. Think about it, what issue? Give you some tips. It's called, because firewall have one core mechanism, and that mechanism is called stateful inspection mechanism. Stateful inspection mechanism, right? the firewall will check the first packet. When a packet received by the firewall, the first step for the firewall is to check whether this packet can match a existing session entry, right? This is step 1. If the packet cannot match a existing session entry, which means this packet may be a first packet of one data stream, right? So the second step, the firewall will check whether this packet is the first packet of one data stream. If it is a TCP application, the first packet of one connection should be the SYN and have the correct sequence number. And that's stateful inspection mechanism. And now we have two firewalls. If the accident not happen, which means the traffic still go the left forwarding path. The traffic go this way, the left side. Okay, then all the traffic, all the TCP link were established across this forwarding path, right? Which means the firewall 1 have the session entry. The firewall 1 has all the session entries, right? And the rest part of the traffic just cross through the firewall by matching the session entry, forwarding the traffic normally, fast and good. And which means the firewall 2 don't have any session entry, right? Because by default, the active device forward all the traffic. The traffic is all forwarded by the active device, and a backup device has no traffic, right? Zero traffic, which means the firewall 2 do not have any session entry. And now the switch just happened, which means the accident happened, network failure. The firewall 1 and SW1, the link is down. Okay, the VRP group 1 changed to the active status changed to firewall 2, and VRP group 2 active status changed to firewall 2. Then the firewall 2, both the downlink and the uplink send gratuitous ARP to the switch 1 and switch 2. Refresh its MAC table. Then the traffic immigrate to the firewall 2, the right side, right? But the traffic once arrived the firewall 2, the firewall 2 will check the session table, and the firewall 2 find out there is no session entry in its session table. So the firewall 2 will check those traffic, whether they are the first packet or not. But those traffic actually, it's supposed to forwarded by the firewall 1. So it definitely not a first packet. Maybe the second one, third one, the 101, because they match the session entry on firewall 1, but no firewall 2. So the firewall 2 make its judgment. Wow, all those traffic I received. It is not the first packet, so I'll drop them. I think they are legal. They are not legal. They are not first packet of one data connection. So I'll drop all this traffic down. And for the PC and server, because the connection is down, they need to re-establish the TCP connection, right? And that's horrible. And it still costs the traffic down, and it still costs the business down, right? Because of the stateful inspection mechanism. So this is the problem. Maybe the traffic will down several seconds or several minutes because of the shift, the status shift, right? And firewall 1 and firewall 2, they haven't synchronized their session entries. That's the reason. So in order to resolve this problem, we still need another protocol, and that is called HRP. HRP. Huawei Redundancy Protocol. And the function of HRP is used to synchronize the session entry between the firewall 1 and firewall 2, between the active device and backup device. So they have the same session entry. They maintain the same session entry. So when the shift happens, the firewall 1 becomes the backup, and the firewall 2 becomes the active. The traffic shift to the right side forwarding path. And it is because firewall 2 have already synchronized the session entry from the firewall 1. So the traffic can still forwarded by the firewall 2. Okay. This is the logic, the main logic of dual system hot standby. Three key technologies. First, VRP. And it is because VRP do not synchronize its status for each other. So we need a VGMP. Yeah, the VGMP can control one VRP group change its status. The rest of the VRP groups change at the same time, but it still causes some problem. The problem is the firewall 1 and firewall 2 don't synchronize its session entry, their session entry. So when traffic switch to the backup firewall, because of no session entry and stateful inspection mechanism, the traffic will drop by the firewall 2. And in order to resolve that problem, we have the third protocol, Huawei Redundancy Protocol, in order to synchronize the session entry between the active firewall and the backup firewall. And that's perfect. All the problem just resolved. Okay. And it's almost about the time. I think it's about time to end today because it's already 11 a.m. And tomorrow, I'll show you how to deploy the dual system hot standby on Huawei firewall. All right. So today, do you have any questions? Any questions from now on? Okay, good. No question. So let's end today. Class is over now. Today. And see you tomorrow. All right? Okay, see you tomorrow. Goodbye. Yeah.